Hi everyone, in this section, we will integrate an API gateway to our architecture. Let's go over on API gateway properties. API gateway is an API management tool or service that serves as a reverse proxy and routes the request from client to server. It accepts the request as a first contact point and applies some filtering on requests before forwarding it to backend service. Client can only know and communicate the API gateway, and backend services can be hidden from the client in case we use an API gateway. An API gateway can be used to aggregate data over multiple backend services. It can also be used to apply authentication, rate limiting, and circuit breaker functionality to be applied to all backend services. We will use Spring Cloud Gateway, which can be enabled with Spring Cloud Starter Gateway dependency. Spring Cloud Gateway can be configured using config file or in code. There are some important terminologies on configuration of Spring Cloud Gateway. We have routes, which is used to forward the request to a URI. We also have predicates to match a request, such as using header or URI. And we have also filters, which are used to modify requests and response and to apply filtering like circuit breaker or rate limiting. We will apply rate limiting using Redis in our examples using Spring Cloud Gateway. This rate limiter solution is based on Stripe. You can check about it more at stripe.com. We will use Spring Boot Starter Data Redis Reactly dependency, which will enable using Redis as the data store for rate limiter. It uses token bucket algorithm by default. We will create a filter named request rate limiter first, and then define a key resolver to be used in mapping in rate limiter. There are three important properties to be defined in rate limiter. First one is the replenish rate. This is the rate at which the token bucket is filled. It defines the request per second a user is allowed to do. Burst capacity is the maximum number of requests a user allowed to do in a single second. It can be used to allow for a temporary burst up to this number. It also sets the number of tokens a token can hold. Setting this to 0 blocks all requests. And finally, we have requested tokens. This property defines how many tokens a request costs. This one defaults to 1. Any request goes beyond rate limits will result in HTTP 429 too many requests as a response. As an example, with replenish rate 5, burst capacity 10, and requested tokens 1. Token bucket will be filled by 5 in each second, but with a maximum number of allowed token as 10. User can send 10 requests at first second, as burst 10 is allowed. However, cannot send another request until second 3, as the allowance of 2 seconds already spent in the first second. We will also apply circuit breaker for our services using Spring Cloud Gateway. We will add Spring Cloud Starter Circuit Breaker, Reactor, Resilience4J dependency, so that we will use Resilience4J implementation for our circuit breaker. We will then define a filter named circuit breaker and define fallback URI for each service. We will also customize Resilience4J configuration using a configuration class. Resilience4J circuit breaker is implemented using a finite state machine with 3 normal states: closed, open, and half open. To aggregate the results of calls, it uses a sliding window, either time-based or count-based. Here are the basic transactions on the state machine. Close to open occurs when failure rate is equal or greater than the configurable threshold. For example, when more than 25% of the calls failed. Close to open transition can also occur if slow call percentage is equal or greater than a configurable threshold. For example, when more than 25% of the calls took longer than 5 seconds. After the configured wait duration passes, the state can transit from open to half open, where it has configured amount of calls allowed. And half open to open transition occurs if failure rate or slow call rate is still equal or greater than a configurable threshold. And finally, half open to closed transition occurs if failure rate and slow rate is less than a configurable threshold. Here we see the circuit breaker properties for Resilience4J implementation. We have failure rate threshold. When failure rate greater than or equal to this value, circuit opens and starts short-circuiting. It defaults to 50. For slow call rate threshold, when slow call rate greater than or equal to this value, circuit opens and starts short-circuiting. This one defaults to 100. Slow call duration threshold is the duration threshold above which calls are considered as slow. This one defaults to 60,000 milliseconds. Permitted number of calls in half-open state is the allowed calls in half-open state. Max wait duration in half-open state is the maximum wait duration that circuit breaker can wait in half-open state. This one defaults to 0, it means the application would wait infinitely. Sliding window type is the type of sliding window used to record the outcome or calls when circuit breaker is closed. This is defaults to count-based, it can also be time-based. Minimum number of calls is the number of calls required per sliding window period before the failure or slow rate calculated. And finally, wait duration in open state is the time that circuit breaker should wait before switching to open to half open. Alright, after having some theoretical background, we will now implement the gateway in the next lecture.